Okay, so we're going to be talking about what rational expressions are tonight and how to evaluate rational expressions. We will get into how to simplify rational expressions in this chapter. We will also solve rational equations, so equations that contain rational expressions as the chapter progresses. Tonight, we just want to start with the definition of what a rational expression is. A rational expression is defined as a ratio of two polynomials. Oops, sorry. Okay? P over Q, where Q cannot equal 0. It's an algebraic expression that's a fraction, pretty much is what it is. Okay, so you're going to have variables in it. They could be in the numerator, they could be in the denominator, they could be in both, and it's a fraction. And Q, the denominator cannot be 0, because if the denominator is 0, then the fraction is undefined. Okay, so that's just the general definition of it with P's and Q's. We're going to start just with looking at one that's pretty simple, and we're going to evaluate it at a certain value of x. Okay, so I'm going to give you a rational expression, x plus 1 over x minus 3. And I'm going to ask you to evaluate this where x equals 0. So part A, evaluate this for x equals 0. That means you're going to put 0 into this expression for x and tell me what it equals. So it would be 0 plus 1 over 0 minus 3, which is 1 over negative 3. Now, we had this discussion today actually. It is inappropriate, it's considered inappropriate to leave a negative in the denominator. I don't know if you know this or not. It's not wrong, it's just inappropriate. And I always use the example that it's not wrong for me to hop around on one foot all the time or stand up here on one foot all the time. That's not wrong, but it's just not acceptable, right? It's just kind of weird and distracting and all that. So in math, this is just considered unacceptable. So what we do is we put it in the middle, but I also want you to be aware that this is the same thing. So middle or top are considered appropriate. In the bottom is not considered appropriate. Okay? So I'm just simplifying. But all three of these fractions are the exact same fraction, aren't they? Okay? Part B says let's do it for 3. So let's evaluate it for x equals 3. So I'd get 3 plus 1 over 3 minus 3, which is 4 over 0, which is what? It's undefined because 0 is where? In the denominator, right? So if it's in the denominator, if you typed in your calculator, y'all know a fraction bar means division. So if you typed in 4 divided by 0, your calculator would give you an error message because you can't do it. You can't divide by 0. So this is undefined. It is super important that you know if 0 is in the bottom, it's undefined. If 0 is on top, it's equal to 0. Okay? So would you say that this particular rational expression is defined for all real numbers except when x is 3? Could you make that assumption? Let's think about it. Can x be any number except 3? Sure. I can take any number except 3 and add 1 to it and subtract 3 from it and get a fraction, right? Get a simplified answer. Okay? But 3 causes it to be undefined. So that leads us into the next little topic, which we would say on this problem, 3 is excluded from the domain, which that's not how your book says it, but I'd already started my statement, so I'm going to finish it. 3 is excluded from the domain, or the restriction on X is that X cannot equal 3. So basically, you have to look at your rational expression and decide where the denominator would be 0. What value of the variable causes the denominator to be 0? And that's where the restriction is on that variable. Okay? We're going to do some more of those where we talk about the denominator. All right, so let's go with another pretty simple one, and let's just, the directions have changed. We're not evaluating it. We are just going to talk about what is the restriction on the variable. Okay, so here's my rational expression. What is my restriction on X? So what you have to ask yourself is, what value of X would cause my denominator to be 0? And that's where it'll be restricted. I recommend, if you're not real good at just seeing it, take it and write it as an equation with a slash through it. Okay, so say X plus 4 cannot equal 0. Because that's true, right? This cannot equal 0. So you would subtract 4 from both sides to solve that, and you would get that X cannot equal negative 4. Because negative 4 plus 4 is what? 0. Okay, so X cannot equal negative 4. So your restriction is that X cannot equal negative 4. Done. Okay? If you have a denominator that's a little bit more complex, like this one, we're going to find the restriction on X, then you really probably do need to do this. You probably could have seen this one, determined it was negative 4, if you just thought about it a little bit. This one might be a little bit harder for you because there's a coefficient on X. So you're going to come over here and go, well, if I'm looking for the restrictions, 3x minus 2 cannot equal 0. So I'm going to add 2 to both sides of the equation. 3x cannot equal positive 2, and then divide by 3. So X cannot equal 2/3. X can be any number except 2/3. When I put 2/3 in here, 3 times 2/3 is 2, and 2 minus 2 is 0. Okay? Your book calls this a restriction. A lot of textbooks call it excluded values. Okay? And you need to be flexible with that because textbooks vary from course to course. So it could be something that you just need to be able to kind of be flexible with. As long as you understand the concept, you should be good. All right, so let's move into a little bit more difficult one where we're going to look for a restriction on a variable, but it's not quite as simple as that. So we've got this rational expression, t minus 5 over t squared minus 7t plus 12. And I want you to tell me the restrictions on t. So I'm looking for where the denominator would be equal to 0. You're going to come over to the side and you're going to set the denominator not equal to 0. So just work it like it's an equal sign. This is just a not equal sign. You should remember that to solve this, you have to factor this first. I'm sure you did that. Okay, good. So you're going to factor this trinomial just like we just reviewed. t and t. And then factors of positive 12 that add to be negative 7 are negative 4 and negative 3. And then, of course, we set each one of those equal to 0 and solve. In this case, we're setting them not equal to 0. Okay? So t minus 4 cannot equal 0, and t minus 3 cannot equal 0. I would add 4 to both sides. I'm not going to show that. T cannot equal 4. I would add 3 to both sides. So t cannot equal 3. So my restricted values are that t can't equal 4 and t can equal 3. All right. Do you have any questions so far? All right, let's do another one. X plus 4 over x squared minus 9. And I want you to tell me the restrictions on x. So again, you only are worried about the denominator because the denominator is the only thing that can cause problems. So you take x squared minus 9 and you say it cannot equal 0. So this is the problem. Here is where I start thinking and writing my work. That's a difference of 2 squares. So you're going to factor it into x plus 3 times x minus 3. And you would set each one of those equal to 0 using your zero product property that you learned in 098. And solve. So you'll get that x cannot equal negative 3 and x cannot equal positive 3. Any questions? Okay. We are going to